It's 2:17 a.m. Your servers are under heavy load, and suddenly the hardware gives out. Orders halt. Payments drop. Users abandon ship. At this moment, the individual lines of code you've written, no matter how elegant, cannot save you. Code provides the instructions, but it's the architecture that provides the floor. If you haven't engineered that floor to support the weight of 1 million users, the entire product will fall through it. Building a resilient infrastructure begins before a single script is ever written. It starts with defining the exact parameters of the reality you are trying to build. You have to step back and ask, who is actually using this, and what precise problem do they need solved? Achieving strict clarity on that core user journey, mapping out exactly how someone will search, click, and purchase, is your strongest defense against structural chaos later on. Once that problem is defined, we have to establish the rules of our digital environment. Every system is bound by two distinct categories of constraints that determine whether it lives or dies. First are the functional requirements. These are the highly visible, everyday actions a user expects to perform, things like logging into an account, browsing a catalog, or hitting a checkout button. Second are the non-functional requirements. These are the invisible structural traits dictating how well the system performs under pressure. It's the speed of a database query, the sheer load capacity of your servers, and the security of user data. Digital products rarely collapse because they lack exciting new features. They fail because engineers focused on the individual logic of a button while neglecting these invisible foundational constraints. This schematic maps 3 distinct blocks of a scalable ecosystem. The front end is the display environment, capturing exact user commands. The backend is the processing brain, executing business logic and hidden decisions. Finally, the database is the permanent memory bank, securely holding all transactional reality. The survival of your application relies entirely on maintaining a frictionless, unbroken flow of data straight through these 3 pillars. Relationships between data points form the system's backbone. A user connects to orders, which map to products. You choose how to store this reality. Enforce a strict grid using an SQL database, or use the fluid architecture of NoSQL, grouping data into independent documents. Moving a step up to the routing layer, all of this stored information has to be communicated back and forth through APIs. Think of these as highly specific conversations, moving data between isolated components. When you define clean, exact API endpoints, information flows efficiently to its destination. A messy routing layer guarantees dropped requests and confusing internal dialogue. Managing those requests is the backend logic chain. A single request triggers a rapid, sequential cascade of invisible operations, verifying warehouse stock, calculating tax, pinging the payment gateway, and securely saving the final receipt. To the user, everything feels as simple as tapping a screen. Beneath the glass, you aren't just writing the code for that one tap. You are orchestrating a massive, meticulously synchronized web of micro-decisions. That synchronization holds up fine for 10 or even 10,000 daily visitors. But eventually, you hit a tipping point where a manageable stream of traffic suddenly spikes into an overwhelming, massive wave, accelerating toward your infrastructure. This animation shows the first line of defense against that surge, the load balancer. Instead of letting a heavy traffic stream crush a single fragile point, it catches the data and splits it perfectly across multiple parallel servers. To accelerate response times further, you implement caching. This creates a high-speed memory bypass that remembers the answers to frequently asked requests, bouncing the data right back to the user without ever taxing the main database. To prevent the permanent memory banks from failing under the sheer weight of millions of read and write requests, the primary database clones itself. Multiple identical cylinders now pulse in sync to share the downward traffic flow. Architecting for scale is the price of admission for any system intended to survive in the real world. But even with those fences, we have to confront the hardest truth in engineering. Eventual catastrophe is certain. Hardware will burn out, network cables will be cut, and payment gateways will break down. You cannot achieve physically impossible, perfect uptime. True resilience means engineering automated retry mechanisms and graceful fallbacks so that when a component inevitably dies, the system routes around the damage and recovers instantly. You also have to treat security with that same baseline rigor. Encrypting passwords and strictly validating inputs are silent, foundational responsibilities that protect your most critical asset, user trust. A poorly designed architecture collapses completely the second it's put under pressure. A masterfully built environment absorbs the impact, adapts, and survives. The most resilient systems aren't the ones with the most features. They are the ones that prioritize clarity. Because complexity you can't understand is just technical debt waiting to trigger a failure. So when that massive traffic spike hits your servers again at 2:17 a.m., your system holds steady. Notifications flow smoothly, and the crisis is averted. By shifting your focus from the individual line of code to the broader architecture, you do more than just build an app. You are designing the invisible infrastructure that runs the modern world.